Okay. So yeah, I can see your very less members today. Anyway, good morning to all. So let us move on screen sharing. Okay. So today again let us go through the quickly whatever we discussed yesterday. So as you guys know that we are discussing wave optics. We know that optics is a big area of research where people are working like anything to explore material properties, etc. So wave optics is the one which can shoot anything of the material properties. Like you want to know the properties of like a material like silver, gold, etc. You want to shoot this light to the gold or platinum, any material. So what it extracts the properties. So what kind of properties? So it gives the what are the molecules present in the material, what are the atoms present in the material, and it also gives the information about the structural information of the material. So like electron diffraction, which gives the structure of the material, uh, neutron diffraction, etc. So from light, you'll have a lot of applications in day-to-day life. You can make any device like solar cells, counting machines, sensors, etc. A lot of advantages are there with the optics chapter. So optics means, when I say optics, definitely it's immediate. We have to think about light. What kind of light? What is a light actually? So light, we know that light is the one which has a basically very beginning we were saying that light consists of particles, corpuscles. We used to call that. Okay, and Newton was the one who pointed out this, and we call that Newton corpusculars theory, in which he always focused on the light is a light consists of particle called photons. Okay, they have the different sizes. Based on that, we used to say different wavelengths. Okay, and later on, the Huygens is the one who proposed the theory called wave theory of light. So which is very important, and they did a lot of experiment with the wave theory of light. And wave optics is the one, basically, as I just mentioned, Huygens is the one who first discovered the wave theory of light, and he developed a lot, and he explored like anything, uh, and used this theory to explore many properties of materials. The first so in 1678, he was the first person who was looking into the wave theory of light. But in that time, Newton was the he was ruling, I can say. He was the one who dominating the entire field. But no one was accepting the Huygens. Whatever Huygens proposed the wave theory, no one is accepting. So, but he was still arguing the things. No, definitely light is a combination. Light can propagate from one point to another point in the wave pattern. So no one is accepting, but still he was fighting with other scientists. Finally, there is a scientist called Thomas Young. You can see here there is I just shown here, on the right side there is a theory called Newton's theory. Corpuscular theory of light. So you can see candle, from candle of this point, the light can propagate in all direction in a point wise. These are called particles. So the particle interact with this eye, whatever we can see the light. And the left side, you can see there is a theory called wave theory. So he is the one, Huygens, who was actually discovered the wave theory. Okay, and it can be like wave pattern, the waves coming out of the point in a wave pattern. Okay, uh, then moving into, so you can see clearly here, this is a person Huygens, Thomas. Then as I mentioned just now, it was a big fighting between the wave theory and particle theory. So then there is a scientist called Thomas Young, is the one who proved the wave theory by experiment. So basically it is proved, it was proved that time experimentally the light can propagate in a wave pattern. On the right side you can able to see. So let us say when you drop a object into the water, okay, what happened? You can see the waves around that particle, okay, that object, and it can be represented. On the right side, you can able to see that how wave is changing. Dependent. So what is wave actually? Wave. What is wave? So wave is definitely, it has its own characteristics such as wavelength, amplitude, phase, frequency, etc. What are all these stuff? What is the amplitude, I can say? So on the right side, you can able to see the wave amplitude. Basically, see, you can see here how wave is changing its wave amplitude. So you can able to see, I guess, mouse, the distance from the mean position, that the maximum displacement, this is the maximum displacement from the mean position, is called amplitude. So you should know this. So amplitude is the maximum displacement from the maximum displacement from the mean position. Okay, so it's basically what is the wavelength. So to know the wavelength, definitely we have to understand the concept of various types of waves, transverse waves, longitudinal waves. What are the longitudinal waves? What are the transfer waves? So I mean, basically, we're going to discuss this entire topic in the waves chapter. We have a waves chapter too. So the I mean, you can able to clearly see the wave pattern. So can you able to see, guys, how wave is propagating from the point? So now another so that time basically the wave theory did not accept by the scientists. Okay, so later on there is a scientist called Maxwell who developed the theory of electromagnetic theory. What is this, sir? So electromagnetic theory is the one where you have the electric and magnetic fields are there. So how can we get this? So when a charge, let us take an electron charge. When a charge moving with respect to time, when a charge is moving with respect to time, let us say electron is moving with respect to time. So what you're going to observe, electron is a charge, you have the electric field. When electron is moving, definitely around there is a magnetic field. So Maxwell is the one who developed the electromagnetic theory. So what he was looking, so these electric and magnetic fields, suppose changing electric field can produce the magnetic field. Sir, what is this? So when a electric field is changing with respect to time, when electric field is changing with respect to time. Which means what? Field is basically, it's not a rest. Suppose electron is moving, which means what? Electric field is also changing with respect to time, right? So any changing electric field can produce the magnetic field. Sorry. So any magnetic field also, the magnetic field which changing with respect to time can also produce the electric field. So this is the main, important concept of Maxwell's. So these two fields are associated together and can be produced from one each other. Okay. And you can able to see clearly in the bottom, which I shown here, this is an electromagnetic wave. It's a very tremendous, right? You can able to see clearly. I mean, we don't know, right? Like when we call it, so you are calling a phone to your friend who is in America, who is in Australia. How we can able to catch your call? In the form of electromagnetic waves, right? So there is a communication in the form of waves, which are called electromagnetic waves. They should have the particular range of frequency in order to propagate wave from one country to other country. So we're going to discuss that concept in communication chapter. But here you should know the wave can be like this. The wave can be like this. So the wave is basically, it has two fields. The electromagnetic waves you can able to see here. One is the red color is electric field, the green color is magnetic fields. They are they're moving in a direction of perpendicular to these two fields. So electromagnetic wave is the one in this. Electric and magnetic fields are perpendicular to each other. Okay. So this is the electric field, this is a magnetic field. These two are perpendicular to each other and they also perpendicular to the propagation direction. The propagation direction means the wave which is moving direction. So electric field, magnetic field and the propagation direction. So they are mutually perpendicular to each other. And we'll discuss that again in the electromagnetism chapter. So now here I just want to introduce the waves. Wave is the one which has a specific characteristics which can carry the energy from one point to the another point, carrying the information, carrying the energy, etc. Now the question is, here Huygens is the one. Huygens is the one of the famous scientists. As I mentioned just now, he developed the wave theory, right? And here, what he was considering that a locus of points, okay, a locus of points which oscillate in a in phase. What is in phase and out of phase? I'm going to discuss that. We call it as a wave front. What is the wave front? Wave front is the one which is basically, it is a point which oscillate in phase, means same, like the two waves are coming from a source. Let us say one wave is coming like this, there is another wave is coming from another point. If they are in phase, means same time they located, same time they generated from the point, they have the zero phase. In phase means they have a zero phase, zero angle. Okay, so we call it as a wave front. You can see simulation on the right side, bottom of my slide. There is a dot actually. Initially it is a dot, but you can see here there is a dot, but from that dot you can able to see waves coming out, right?
So what is Huygens principle? Each point on the wave can source for the next wave. We call it as a wavelets. So this is the point. Can you able to see my mouse where I place? That is a point. From that, there is a wave come out, right? There is a wave is coming out. Another wave is coming out of this wave. Every point of this circle or sphere, you can able to see. Every point on this sphere can act like a source for the another wave. So okay, we call it as a wavelet. So now we understood wavefront, a locus of point which oscillate in phase, means all waves are coming out of the same time. That is called wavefront. The locus of point which have same amplitude. Same amplitude means the wave, the maximum displacement should be same and vibrate with the same phase, which are called spherical wave. The spherical waves are coming out of like this. They are coming in phase. They have the same amplitude. We call it as a spherical waves. You can see the mouse. So they are coming the same time in phase. So after that, so now you can see how the waves are coming out of different waves, black color. Okay. So when you see the, so now you can see, sorry. So here you can see the, plane wave. When you look at this spherical wave in a long distance, a small portion of the spherical wave can be considered as a plane wave. What is a plane wave, sir? Plane wave is basically very simple. So initially it is a sphere, right? When you are moving away from this point, what happened? At the large distance, the sphere become a plane wave, like a straight line. So that is called plane wave. So Huygens principle is the one. Each point of the wavefront is a source of the secondary disturbance. We call it as a, what do you call, wavelets. So now, as we discussed yesterday, reflection of plane wave, reflection of plane wave by a surface called, you know, by a surface called plane surface. What is this, sir? Can you able to see right side? There is a simulation of video. So you can think about this here. Right side, I shown two figures. One figure is Mn is the reflecting surface, like a mirror, beta. It is a mirror, and AB is the one which is actually wavefront, which we were discussing. Wavefront is kind of like, it's a complete wave, plane wave or spherical waves. So wave, here you can think about, okay, AB is the wavefront, Mn is the reflecting surface. When AB incident on the, when AB incident on this reflecting surface, it takes reflection, right? So A is here and B is here. When B reaches C, A reflected back to the E. So here I mentioned, let us consider a plane wave AB incident at an angle I. So this is the incident angle I, okay, and on a reflecting surface Mn. Suppose to reach a point B to C, the wave should come from B to C. It takes some time, right? Let us consider T time. T is the time. And what is the distance from B to C? So distance can be velocity into time. So if the V is the speed of wave front and T is the time taken by the wave from B to C, then the total distance from B to C, how much? Velocity into time. Okay. And that is going to be, so now we need to understand, we need to construct the spherical wavefront, right? So we know the Vt. So Vt is the basically radius of our sphere, and bottom you can able to see it. So how the wave is coming out? My mouse you can able to see, I guess. The waves are coming out of this, reflecting surface. See, blue one is coming, Another blue one is coming spherical wave. And if you can able to construct spherical wave from this radius of BC, okay, so you have the spherical wave construction. You see how the wave is coming? This is a spherical wave construction with a radius of Vt. From this diagram, you can able to see when B reaches C, A goes to E. So you can construct with the arc, compass. With using the compass, you can make the radius of Vt. These two triangles are similar triangle. So from figure, what we can have? AE is equal to BC. AE is equal to BC. So which means it's a same distance, V into T. So from these two triangles, what you can observe, these two are similar triangle. So the angle of incident, whatever angle is here, that must be same as here. So that means what? Angle of incident must be equal to angle of reflection, which is the principle of what? Law of reflection. I hope it is clear, right? Is it clear?
Yes, sir.
Okay, we have discussed yesterday, but I just want to go through again because the new members joined today. And the next slide, we're going to discuss the refraction of the plane wave by surface. So what is this actually? You can see on the right side, now we have the this is a different surface beta. The previous slide is basically, we were discussing a reflecting surface. This is a kind of like a mirror. In the previous slide, we showed like a mirror. But here, the light can passes through the medium. So here you can think about two different medium. You can think about, this is the one medium, the other one is different medium. Like, air and glass, air and water, different medium. When the light passes from one medium to other medium, definitely it takes the we have a okay, give me 1 second. So when light passes from one medium to other medium, give me 1 second. I think it's okay. Okay, so when light moves from one medium to other medium, definitely it undergo the refraction. Refraction is the one which is basically the light basically bending from when it moves from one medium to other medium. When it moves from, let me find my mouse here. Okay, so you can see when light moves from medium 1 to medium 2, it bends. You can also think about better, like when you keep the stick, take any stick, any metal rod, you insert into the water, you can clearly see there is a deviation from its original path. So that is actually refraction. Okay, so when light basically when light moves from the when light incident on the prism also, it undergo the refraction. So here, so you can clearly see PP prime. This is the refracting surface which separate the two medium, and the velocity of light basically, the wave front here V1, here is V2. The medium 1 is velocity is V1, the medium 2 wave velocity is V2. So let a plane wave front AB. AB is a wave front which is actually incident on the P prime surface sorry, with an angle incident I, and the distance we measure, as I mentioned previous slide, V1 into T, because velocity into time. Similarly, to construct wave front in other medium, what we have to do? Definitely we know the radius, so same radius, okay, same radius, we have to BC, as I mentioned here, V1 T, So when you are constructing the refractive wave in a medium 2, so what we have to do? So you can see in the figure, same radius v1t, it's a v2t, but different velocity. It's not v. The previous slide we were discussing same speed of wave because it's the same medium. But when medium changes, its speed changes. So we are writing here v2t. These two are similar. So v1 is the first medium, is v2t. Okay. From this, what we can write? These two triangle, okay, ABC, AEC or similar triangle. So what we can write, sin I is equal to AB by AC. Sin I from this triangle, sin I is equal to AB by, this is the angle I. So from here what? So AB by AC, which one actually? Velocity. So it's actually BC, Nana. Wrong, I just mentioned here AB. It's a BC basically. BC is the opposite angle, right? Opposite side by hypotenuse. So BC by AC. So I mentioned here AB, which is wrong. You can correct it. BC by AC. So BC we already mentioned in the diagram, V1T by AC. Similarly, you can calculate the, in case of refracted ray, sin R. Angle of refraction is R. So sin R is equal to basically what? So it's so AE by, so R is here, right, it is right, AE by hypotenuse AC. So AE is again V2T. So V2T by AC. When you divide these two equations, what we're gonna get? Sin I by sin R is equal to V1 by V2. Now the question is, so we call it this as actually Snell's law. Okay. So basically it's a ratio of sine of angle of incident to the angle of refraction can be, it's a ratio of the velocities in two different medium, and there is a relation you can able to see. It's inversely proportional when you are talking about refract angle, like coefficient of refraction. So sorry, refractive index. N1, N2 are here refractive index. So N1, N2 are basically refractive index of the medium 1, refractive index of medium 2. So the ratio of these refractive index is inversely proportional to the speed of the wave in two different medium. Okay. So then again coming here, Doppler effect. So what is Doppler effect? So Doppler effect, we know that it's a relative concept. Okay, it is a relative concept. We have only 3 minutes, beta. So again, uh, we just need to complete this Doppler effect. Then I'll summarize it. So Doppler effect is a concept which is apparent frequency of light caused by the relative motion of source and observer. What is this meaning, sir? Suppose there is a light and observer. Okay, think about light, laser light, any light. There is an observer. They are in relative motion. They are not in sitting in one place. They are in motion. They are moving with respect to each other. Suppose a light is here. The person is moving towards the light and moving away from the light. Suppose you can consider in your home, this a light is here. When you are sitting close to the light, you can see different concept, different feeling. When you are moving away from the light, you are moving away from that room to another room. Definitely, there is a different, sight you can see, right? So when waves are received from a source moving towards the observer, suppose you are moving towards the observer, like you are bringing the light towards you. You are sitting one place. I am bringing the light towards you. So you can feel that the intensity increases, right? The wavelength actually decreases. The frequency increases, wavelength. So it's coming close to you, right? That is called blue shift. Suppose the light is moving away from you. You are sitting one place. Okay. I am bringing the light from your place to other place, away from you. So in that case, what happened? Wavelength is increasing, but frequency decreasing. That is, we call it as a redshift. So the Doppler shift can be expressed as a ratio of the frequency delta V nu by nu. Okay, this can be the shift, which is also can be represented as a nu by c. Here we consider speed of wave. Basically, it is equal to the speed of light, 3 into 10 power 8 meter per second. Okay. Then what happened? This shift can also be represented as a minus delta lambda by lambda and nu by c. And from here you can calculate the Doppler shift. So Doppler shift, don't think about abstract. This very simple concept. With using this, you can able to calculate the relative, radial speed of galaxies, planets. Lot of applications are there. Okay, so it's not a it's a relative concept. So we also talk about Doppler effect in sound, but here light is, you're talking about light source and you. When light is coming towards you, it's different intensity of light. When light is moving away from you, different. Like you can think about a car, a lorry with a light. It's approaching you. You feel like an intensity increase. A lorry is moving away from you. You feel like intensity of light decreasing. These two concepts are Doppler effect. Once it is approaching you, it's a blue shift. If the lorry is moving away from you with the lights, that is called red shift. Okay. This is about Doppler effect, and we're gonna discuss tomorrow. Very important concept: interference. What is interference? What are the properties?